Yes, so basically in this question we wanted to find out the smallest value of the rearranged number. So we are given one number 310 as input. We want to find out the smallest possible number that we can form out of it, given that we don't want to have 0 at the first position, or basically we do not want any 0 as prefix to the number, because that would not have the same number of digits as in the original number. So there are some examples. 310 would turn out to be 103 because 013 is not a possible answer for us. Similarly, minus 7605 would turn out to be minus 7650. So one thing which we can notice from here is that whenever a number is already negative, we try to like if I just ignore this minus sign and I just consider 7605, I would try to make it as large as possible since there is a minus sign before it already. So in that case, I would like the maximum number that I can form out of 7605 would be 7650, and with the minus sign before it, it would become the minimum possible number that I can form. So yeah, that's the question for us. Now if I just go about the implementation, the initial approach for thinking about it would be given a negative number, we would basically want all the larger digits to come in the front and the smaller digits to go back. So basically we would need to, if I just extract all the digits of this number and keep it in an array, I would sort that array in the descending order such that all the larger numbers come to the front and the smaller numbers go to the back. So it's very simple in case of the negative numbers, that I just need to sort it in the descending order after extracting the digits out of this number and reconverting back into a number. But in the case of a positive number, there are two possible scenarios which we need to separately account for. One is the normal scenario wherein we are not having any 0 in the number. In that case, we would just need to sort the number in the ascending order and form the number out of the existing digits and return that. For example, in the scenario wherein we have only 3 and 1, we can then sort this number into 1 3, and that would be the smallest possible number we can form out of 3 1. But in this scenario, like in the example given, 310 is the number. If we extract every digit out of this number, it would be 0 1 and 3, and if by chance I try to sort it in the ascending order, it will come out as 0 1 and 3. Since it is not allowed to have a 0 in the forefront of the number, we would have to separately account for this scenario. Basically, if you would just look here, so it's very clear here, like the possible numbers that we can form out of this 310 are these possibilities. All we have done is we have moved this 0 to the position where we have found the minimum possible the number where we have non-zero, the index where we have the non-zero digit. So basically we try to move this first non-zero element that we encounter as we move to the right and try to swap it, like try to bring it to the forefront. So basically, like if the first number which I encounter after 0, which is non-zero, is 1 here. So I would try to bring this number to the front. Rest of the numbers would be 0 and followed by the number which is already existing. So let's come to the implementation. This is the main function which we have here. So if the number itself is 0, I would return 0 here. If the number, since the number smallest number in case of 0 is 0 itself, so it's obvious that the answer would still be 0. If the number is less than 0, I basically try to extract the digits here. I store these digits in another array here. This is kind of a global array which I have defined here. It will store all the digits in the number. Okay, so basically if the number is negative, I multiply it with -1 again so that I get the positive number, and then I'm able to extract the digits. I'll come to the implementation of this also. I'm just going through the like high level idea what we are trying to achieve from this function. This is kind of a main function which we use to within which we are calling individual private functions in order to execute our algorithm. So the first step is to extract the digits and store it in an array, which we are having it here. Second step would be, if the number is less than 0, simply get the largest number which we can formulate out of these extracted digits, which we would basically be getting after like sorting in the descending order of the numbers and simply multiplying it with -1 and returning it. And the third thing is the checking if the number itself has any 0 or not. If the number does not have any 0, it's very simple. We would just sort the number. Basically, this is a positive scenario. If the number is less than 0, this is a negative scenario. Here we try to cover for the positive scenario. Now the number, if it does not contain a 0, we would simply return the smallest number here. But if it does contain a 0, we do then try to get the as we move from left to right, we try to encounter the first non-zero element and move it to the leftmost index. Basically we swap until we get the first non-zero element. So let's come to the implementation one by one. Contain 0 is a very simple method. It tries to find out whether a number is containing a 0 digit or not. While n is greater than 0, basically I try to see till the point n is greater than 0. I try to extract the last digit of this number, do n equal to n by 10. If the last digit, whatever that remains out of n, comes out to be 0, I return true, otherwise I return false. Second, this extract digits is a very simple method also. All I do is like very similar to what I am doing here to check the 0 availability. I am just simply looping over the digits of this number from backwards, and mod 10 would be the last digit, and I do n equal to n by 10 each time. I push the digits into this digits array. Largest number formulation would be, I just would be sorting the digits which I've already pre-calculated here in the extract function. I will get those digits here. I try to sort this sorted digits in the descending order. This is the syntax which we follow in order to get the numbers in the descending order. I try to then whatever digits we have got here, we have basically identified the positions where each digit of this number should be in order to get the largest number. I then would loop over each of these digits in this array and try to make this number. This is the way which we follow to make this number. We basically, the first number which we would have, I try to multiply 10 to it. Initially largest number would be 0, so 0 into 10 plus the first digit. So similarly it would, like every time it will multiply 10 to the existing number which we have been successful in making and try to append a new digit to it, and finally we return largest number. The same thing we do for the smallest number, except for the fact that we here sort it in the ascending order instead of descending order, which we did in case of get largest number. Now the interesting part comes when we try to get the second smallest number here. By second smallest number, I'm referring to this scenario. If I just simply sort this number 310 in the ascending order, I would get 0, 1 and 3. Instead I want 1, 0 and 3. So the algorithm which I would follow in this scenario would be, I try to get the first non-zero element as I move from left to right and basically get it to the first position. So I get the basically I get the digits in the globally declared array. I then sort it in the ascending order I try to find the first non-zero element, the index for that element also. So I loop over this sorted digits in the ascending order and try to find the index of the first element, which is non-zero, and the first element itself, which is non-zero. Once I am able to find the index of that first non-zero element, I loop backwards and try to swap basically the element at index and idx and at the index idx minus 1 by 1, until this basically would help me to move this 1 to the first position, basically till the time idx is greater than 0, because if idx is equal to 0, then this idx minus 1 would give me index out of bond, which is minus 1. So once I'm able to do that, I have got the digits in the right position in order to get the second smallest number from this function. I would then simply do a loop over this digits whatever we have and try to formulate this second smallest number and return it. So basically this is the whole approach. I hope